Hello, everybody. What we're going to do today is we're going to follow up on the ideal gas law from last class. You're looking here at the original formula for the ideal gas law, which is PV is equal to nRT. And what we're doing today is I'm going to show you some derivations from this law. If you recall, when you look at the original formula, remember that because we're using this constant down here, which is the ideal gas law constant R, if you recall, the units for pressure, volume, moles, and temperature have to match the units of R. So pressure has to be changed to ATMs, volume has to be changed to liters. If the substance is in grams, you must divide by the molar mass and change to moles. And if the temperature is in Celsius, you got to convert it to Kelvin. Also, don't forget these two values over here with temperature and pressure. If something is at STP, it is very important that you remember those values, because those would be the values that you would substitute for temperature and for pressure. Now, let's talk about the derivations. The first thing I'm going to show you is a derivation where we get the first PV is equal to nRT. And if you recall, moles, which is symbolized by the letter N, is equal to the grams given of a substance divided by the molar mass or molecular weight, whichever one you want to use is fine. So here's what I'm going to do. I'm going to substitute this in place of the N. And when I do that, I get the following. I get PV, and instead of putting N, I'm going to put grams over molar mass or molecular weight times R times T. And right now, what I just showed you here, this entire component is the same thing as moles, and that gives you a new formula. Okay? So you'll use this formula if you're given grams and molar mass instead of moles. You can use this formula. Now, what I'm going to do is I'm going to rearrange this, and I'm going to solve for molar mass. So watch this. If you're dividing by molar mass, you would be multiplying. So molar mass times pressure times volume, okay, I'm making this linear, would be equal to grams times R times T, grams being the regular mass. And if you isolate molar mass, okay, and you divide by PV, you're going to get this, that molar mass can be found by getting the grams times R times T, and then you divide by PV, and that gives us a way to find molar mass. Okay, now I'm going to continue with these derivations, okay? Let's go here to the next page here, and let me write this down. So you just saw that molar mass can be equal to, we'll write this like this, grams, okay, which is mass, times R times T divided by PV. Okay, now I'm going to show you, this is going to be our first derivation. Now, let's get this same formula, and I'm going to show you a new derivation. Watch this. If I get molar mass, okay, let me put grams over here, and I'm going to let me just put the volume underneath here like this. Watch what I'm going to do here. All I did was I just switched places between P and V. It's the same thing. And what I wanted to show you, if you recall, density is grams, which is mass, divided by volume. In other words, D is equal to mV. So if I were to get this right over here, that's mass divided by volume. That's density. So here's what I'm going to do. Instead of writing grams over volume, I'm going to write that molar mass is equal to, and then I'm going to substitute here and put D here for density, okay? So you're going to see that how I do this now. I'm going to put here a D for density, RT. Okay, we can remember maybe the word dirt. And then the only thing on the bottom is the pressure. Over here is on the bottom. So molar mass is equal to density times R times T over P, or dirt over P. Maybe that might help you remember it. So this is our second equation. But sometimes they might ask you to find density. So let's do this. If you multiply molar mass times pressure, I'm going to make this linear. It's equal to dRT. Okay, all I did was I multiplied molar mass and pressure, made it linear. And what I'm going to do here, I'm going to solve algebraically for density. I'm going to isolate density. So when you do the algebra, molar mass or molecular weight, same thing, times pressure, okay, divided by RT is going to give you density. And by doing this, I have just shown you right now that there are several ways or several derivations on how to do this. Okay, so these are the three new formulas that are completely derived from the ideal gas law. Okay, and then next on this next page, okay, I used MW for molecular weight or molar mass, but here's the density equation that I just used. Okay, here's mass divided by molar mass or molecular weight, that's moles. And here are the formulas. Okay, this is if you're solving for mass. Okay, here's the ones I gave you. Molar mass or molecular weight, it's grams times RT over PV. And then I also gave you this one here. Molar mass or molecular weight is equal to DRT or dirt over P. Okay, and then you can always rearrange this last equation here, and you can actually solve for density. Okay, and when you do that, that would be molar mass, okay, on the top times pressure over RT. So we have a few formulas here that we can work with. Now, the key is, when do you know to use them? Well, it depends. It depends on the question, okay? You're going to be looking for certain keywords. So if you see molecular weight or density, you probably know you're going to have to use one of these formulas. So let's take a look here. This is the class practice set number 2. There are 5 problems. So the first one asks for moles. So let's put an N here. Let's see what else they give us. The volume is 5 liters. They give you a temperature of 50 degrees Celsius, and they give you a pressure of 725 millimeters of mercury. Now we're going to use R here. Don't forget that's the ideal gas law constant. I'll write the units down here. And if you look, there's nothing special about this one. I think we're just going to use the regular PV is equal to nRT, and we're just going to solve for moles. So what we're going to do is PV divided by RT will give us the answer. But we have to check for units. As far as I'm concerned, liters is fine, but we got to change this to Kelvin. So you're going to add 50 there to 273, and you're going to get 323 Kelvin. And then the other one that we have a problem, this one's good now, is we have to change this to ATMs. 1 ATM is 760 millimeters of mercury. And that we're going to cancel out here, and we're going to get a new pressure, and that's going to be 0.954 ATMs. Okay? So now we're ready to do the math here. Okay? Now let me give myself a little bit of room. I'm going to erase this for a minute here so I can do the work there. I'm going to substitute. We're looking for N's, which I mentioned is PV over RT. And now that everything is in the appropriate units, we're going to go ahead and plug in our numbers. So solving for N, it's going to be the pressure on the top. That's going to be 0.954, and that's going to be ATMs. And then we're going to multiply that by the volume, which is 5 liters. And then on the bottom, we got RT. Remember, R is your ideal gas law constant. That one has many units. Liter atmosphere, mole Kelvin. And then we also will put the temperature over here, which is 323 Kelvin. And then what's going to happen is the ATMs cancel, the Kelvins cancel, so do the liters. The mole is the only thing left, but that's what we're looking for. So when you do the math, okay, and you'll notice all our lowest number here has 3 significant digits, and you solve for moles, and we round it to 3 significant digits, you're going to get 0.179875 and change. If we round that to 3, it ends up being 0.180 moles, and that number has 3 significant digits. Okay? So that's the answer to number 1. All right, let's take a look at number 2. It says, what mass? Okay, very interesting now. We're looking for mass. Okay, now they also told us it's carbon monoxide, which is CO. They give you the volume, which is 75 liters. They give you the temperature, which is 35 degrees Celsius. They give you the pressure, which is 2.50 ATMs. And then always we got our constant, which is our R. So what we're going to do here is, there's 2 ways to do this one. One of the things you can do is we can solve for moles again. We can do PV over RT equals moles. And then we can multiply the moles by the molar mass and get grams. That's one way of doing it. In fact, I'm going to go ahead and show you that. Now, before we do that, we got to check all our units. And I forgot to put ATMs over here. The only one I see that needs changing is the temperature. So we're going to add 273. That'll become 308 Kelvin. Now we're good there. Everything else looks good. We got liters over here, ATMs. We got this here in Kelvin. So let's plug that information in and let's solve for moles. So we're going to get the pressure on top, 2.50 ATMs. We're going to get 75 liters. And then let's put R down here, 0.0821 liter atmospheres over mole Kelvin. And then our temperature we said was 308. And let's go ahead and I'll show you, we'll cancel our units. Mole is the only thing left. And when you get the answer here in moles, we get, if you round it, we get 7.41 moles. Now, they don't want moles, they want mass, which is grams. So, here's one easy thing you can do. If you multiply the moles by the molar mass, okay, and they give you carbon monoxide, carbon is 12.01 and oxygen is 16, and if you add that up, we can get the molar mass. And let me see here. Molar mass adds up to 28.01. Okay, that'll be grams per mole. And if you multiply the moles by the molar mass by 28.01 grams per mole, okay, again, units will cancel. All right, and we do the math, we're going to get, and we're going to use 3 significant digits here, we're going to get 208 grams of CO, and that would be the answer. Okay, now there is an optional way of doing this. Okay, you could have also used one of the formulas that I taught you. Okay, and look what I'm going to do here. I'm going to erase this for a minute, and I'm going to write that formula down. Okay, let me go ahead and do this, give myself a little bit of space. But here's an alternative way. I'm just going to set it up, and if you use this formula, you can figure it out. You can solve for grams. Okay, if you remember in the derivations, molar mass times pressure times volume divided by RT equals M, which is grams, mass. Okay, so what you do is you plug in 28.01 over here for the molar mass. Then you plug in the pressure over here of 2.50 ATMs. You plug in the 75 liters up here, multiply those three numbers. Then you put down here R, which is 0.0821. And then the temperature at 308. And when you do the math, you will get directly this answer. So you could either use this formula or find moles and then multiply by the molar mass of carbon monoxide, and you'll get the answer. Okay? All right. Let's get to the third one here. An unknown gas has a mass, let me write this in black here, has a mass of 6.150 grams, occupies a volume of 5 liters, and a pressure here of 874 torrs. They also give you the temperature at 23.50 degrees Celsius. Let me just write our R down here. And what we're looking for is the molar mass. Now this, we're going to have to use one of our derivatives. Okay, in fact, if you look at the derivatives that I gave you, the one that where molar mass is already isolated, this is on a formula sheet, so you won't have to memorize this unless your teacher tells you to. But on the formula sheet, you'll have molar mass is equal to mass in grams, okay, times R times T over VP, volume and pressure. Now, before we do the math, we got to make sure that we change torrs to ATMs and temperature to Kelvin. So what we're going to have to do here is remember that 1 ATM is 760 torrs. And that will, let's see what that gives us. That's going to give us a pressure of 1.15 ATMs. And then let's add 273 here. And let's change that to Kelvin. And that's going to be 296.5 Kelvin. So those are the numbers we're going to actually use. Okay? And what I'm going to do here is I'm going to go ahead and we're going to look for molar mass, and that's something I forgot to write down here. We are looking for molar mass, so let's put a question mark down here, okay? Now, if we set it up, the molar mass is going to be equal to, well, we got the mass in grams, so that's 6.150 grams, okay? R is your constant, 0.0821. I'm going to put the units down here, liter atmospheres over mole Kelvin. And all of that will get multiplied also by the temperature, which is 296.5, and that's Kelvin. And then on the bottom, we got a volume of 5 liters, and we have a pressure of 1.15 ATMs. Now remember molar mass, I don't know if you recall, the units are grams per mole. So watch this. Notice how the liters will cancel. So will the ATMs. So will the Kelvin. Notice the only thing that doesn't cancel is grams. And if you look at this right here, mole is on the bottom. Okay, the units that are left are grams on the numerator and then moles on the denominator. So when you multiply the three numbers on the top and divide by the 2 on the bottom, you're going to get, and what we're going to do is we'll go ahead and we can round this to 3 significant digits. I ended up getting 26.04. You could just round that to 26.0. And it's grams per mole. And that's going to be your molar mass. Okay? So 26.0 or 26.04 grams per mole. All right. Now, let's go to the next one. We got 2 more to go. This one's interesting. They want density. So again, we're going to have to use a derivative here. And you'll notice the units of density for gases always comes out in grams per liter. You'll see that. I'll show that as I do the problem. But normally solids are grams per cubic centimeter. Liquids are usually grams per milliliters. But when it's gases, it's grams per liter. Now, notice they say that this is at STP. Here is the importance of memorizing those numbers. At STP, the temperature is 0 Celsius, which we don't really care about Celsius. It's 273 Kelvin. That's the one we need to use. The pressure is 1 atm. These are the two conditions at STP. And they mention H2S as the substance that we're looking for. And I'm going to tell you why that's important. You see, one of the equations that you have is that density is equal to molar mass, okay, times pressure over RT. And if you look carefully, we have the temperature down here. We have the pressure. Okay, R is a constant. What we don't have, and I'll put R down here as the constant, is the molar mass, but we can find it. Okay, using the periodic table, let's find what H2S is. So let me finish writing R here. And then hydrogen, there's two of them. Each hydrogen is 1.01. So when you multiply that, that's 2.02. That would be for hydrogen. And then sulfur is, there's only one of them, so it's 32.07 when you round that. And when you add that up, the molar mass, okay, ends up, ends up being here 34.09. And the units are grams per mole. So that's the molar mass. Now, we can pretty much plug in these numbers and solve for density. So to find density, we're going to get the molar mass that we just found, 34.09 grams per mole. We're going to multiply that by the pressure, which is 1 atm. Then on the bottom, we're going to put R over here, 0.0821 liter atmospheres over mole Kelvin. And then we're going to put over here the only thing missing here is the temperature, which is 273 Kelvin. Again, watch how we get grams per liter. Okay, this is how you could see the moles cancel, the ATMs cancel, the Kelvins cancel. You got grams on the top, and liters on the bottom. Okay, and since really we don't really have any significant digits here, so I usually tell my students, put 3. Okay, so when you do the math here and you solve for density, and I round this to 3 significant digits, you get 1.52 grams per liter as the density of this gas at STP. Okay? All right, we got one more. And this one's very similar to the one we just did, except this one has actual numbers. We're looking for density one more time. This time it's methane gas. We're going to need to find the molar mass in a minute. And they do give us a pressure of 750.5. Notice it's millimeters of mercury. And they give us a temperature here of 75.50 degrees Celsius. And I'll go ahead and write R here as our constant. Okay? So we got to do a few things. We got to change that pressure and that temperature. Let's change this to ATM. So let's go ahead and say 1 ATM is 760 millimeters of mercury. That'll allow us to cancel out those units. And I get 0.9875 ATMs. So now that one's good to go. We're going to add 273 here. And that's going to give us 348, okay, 0.50 Kelvin. So now we're good to go there as well. But we're going to have to find the molar mass of CH4. You see, we're going to use the same formula we did a minute ago, which is that density is equal to molar mass times pressure divided by RT. Now, the molar mass of methane, well, carbon is 12.01. And then hydrogen, there's 4 of them. Each one is 1.01. So if you add, this will be 4.04 here. So 4.04 plus 12.01 will give us a molar mass of 16.05 grams per mole. Okay? Now that we have all our numbers, let's see if we can squeeze this in here. Let's find the density. So the density is going to be equal to the molar mass, which we just found, of methane, 16.05 grams per mole, and we're going to multiply that by the pressure, which we changed already to ATMs, which is 0.9875. And then on the bottom here, we're going to multiply by R. Let me include the units. And then the temperature, we had changed it to 348.50 Kelvin. Okay, and again, I will demonstrate that units cancel. You're going to see we're going to end up getting grams per liter again. The moles cancel, the kelvins cancel, the ATMs. Notice all we got left is grams per liter. Now, when you do the math here and you solve for density, this time we could use 4 significant digits. Okay, I think in this problem it would be okay. Let me do the calculation over here. So when I multiply the numerator, I get, let's see here, the top. Hang in there with me as I do this. Let me see, so I got 15.849375 on the top divided by 28.61185 on the bottom. If I go with 4 significant digits, I end up getting 0.5539 grams per liter. And that will be our answer for this one. Okay? So that would be another density problem. All right, and then just to finish this up, just remember that, you know, these derivations, whenever you see molar mass or density, and they give you those other variables like pressure, temperature, and volume, you're probably going to have to use one of these variations. So keep that in mind. Okay, just make sure, as always, that you match the units, okay, so that they cancel with the R constant. P has to be in atmospheres, temperature in Kelvin, volume again in liters. So don't forget to do that. And remember that molar mass will come out in grams per mole. And if you're looking for density, it's going to be grams per liter. Those would be the units for those two substances. Okay, so hopefully we were able to tie up the ideal gas law with its derivations. All right.